We've all been there, sitting in a doctor's office, a place that just feels inherently safe. But have you ever noticed that swinging door, the one your nurse disappears behind? Well, that's the lab, and it's a whole world of science with its own unique set of risks. So today, let's push that door open and take a look at the incredible, invisible systems that keep everyone safe. So you give a sample, blood, urine, whatever it is, and poof, it's gone. But what actually happens next? I mean, in a room that's full of chemicals, biohazards, and sharp objects, what are the rules of the road that prevent a regular Tuesday from becoming a very dangerous one?
Okay, here's our roadmap for this explainer. First, we're going to peek behind that swinging door to see the hazards. Then, we'll meet the folks who make the rules. After that, we'll learn the language of safety they all speak, check out the lab's internal immune system, and finally, see what the playbook looks like for when things go wrong.
So, first things first, what are we actually protecting everyone from? Because, let's be honest, the waiting room might have some questionable magazines, but the lab, well, the lab has materials that demand constant respect. I mean, just look at this list. We're not talking about anything exotic here, right? This is the everyday stuff of getting a diagnosis: blood samples, chemicals for testing, needles, glass slides. But here's the thing, because each one carries its own little risk, that safety system we're talking about, it's not just a nice idea, it is absolutely essential. So how do you manage all those hazards? Well, lab safety isn't something that's just left up to chance or common sense. Oh no. It is a very carefully designed system, built and enforced by some really powerful organizations. Let's meet the architects. Ah, the big three. You've probably heard of them. You've got OSHA, who's all about protecting the workers. You've got CLIA, making sure the test results are actually accurate. And then the CDC, providing the guidelines to stop diseases from spreading. Think of them as 3 layers of a safety net that covers pretty much everything a lab does. Let's just zero in on OSHA for a second. Their hazard communication standard is beautifully simple, really. It says you can't have any dangerous stuff lying around without clearly saying what it is, how it can hurt you, and how to handle it safely. The big takeaway? No mystery bottles in the lab. Ever. Now this is smart. CLEA knows that not all labs are created equal, so they don't treat them all the same. A simple waved test, think a basic blood sugar check, has way fewer rules than a moderately complex one, where a mistake could actually be life-threatening. It's a tiered system that perfectly matches the amount of oversight to the potential danger. All right, so we've got the rule books, but how do those rules come to life inside the lab? Well, they're translated into a really clear visual language that anyone working there can understand in a split second. And this is a huge part of it, the Globally Harmonized System, or GHS. The goal here is so simple but so powerful. A warning label on a chemical should mean the exact same thing in a lab in Texas as it does in a lab in Tokyo. It's basically the universal translator for chemical safety. And these little pictograms, they're the vocabulary of that language. They're instant warnings. You don't need to speak a word of English or any other language to know that a skull and crossbones means toxic, or that a flame means flammable. It's fast, it's universal, and it works. So, if the pictogram is the big, bold headline, then the Safety Data Sheet, or SDS, is the full, in-depth article. Every single chemical has one. It's the 16-section document that tells you everything: hazards, how to handle it, what to do in an emergency. It is the ultimate safety cheat sheet. Okay, so we've got external rules from the government and universal labels on the bottles. But what about the internal checks and balances? That's where the lab's own immune system kicks in. It's called quality assurance and quality control. Now, people mix these two up all the time, but they are different. Think of it like this. Quality assurance, or QA, is the entire strategy for a winning season. It's the whole playbook. Quality control, or QC, is a specific play you run every single day, like checking the air pressure in the footballs before the game starts. So what does QC actually look like day to day? It's pretty brilliant. Before a lab tech runs your sample, they'll first run a control sample, one where they already know exactly what the results should be. If the machine gets the control sample right, they know it's working perfectly, and they can trust the result it gives for your sample. It's a daily check to make sure the instruments are telling the truth. But, let's be real. Even with the absolute best systems in the world, accidents can still happen. So that final layer of safety is having a crystal clear, well-rehearsed plan for what to do when things go wrong.
Let's start with a fire. The science behind it is actually super simple. It's called the fire triangle. To have a fire, you need three things: heat, fuel, and oxygen. And the secret to putting out a fire is just as simple. Take away any one of those three things, and the fire is gone.
And this is how you do it. To make it super easy to remember when you're stressed, lab pros learn the PASS acronym. You just pull the pin, aim at the base of the fire, not the flames, squeeze the handle, and sweep from side to side. Simple, effective, and really easy to recall in an emergency. The plan for a biohazard spill is just as methodical. The number one rule is don't panic. You just follow the process. You protect yourself with PPE first, then you use the special spill kit to absorb everything. Scoop it all up into a biohazard bag, disinfect the whole area, and then get rid of all your materials in the right container. It's a calm, step-by-step cleanup.
You know, after looking at all these systems, all these regulations and labels and procedures, it really all comes down to this single point. You can have all the rule books in the world, but at the end of the day, safety depends on the personal integrity of the individual professional doing the work. It's all about accountability.
So let's just wrap it all up with this one thought. We've seen the whole system, the rules that come from the top, the tools and labels used on the ground, and the critical role of the people doing the work. In this really complex system that's designed to keep every single one of us safe, which of those three parts do you think is the most important?